Hello, my name is Deborah Duran. I am the Senior Advisor to the Director of the National Institute for Minority Health and Health Disparities on data science, artificial intelligence, and machine learning. I want to welcome all of you on the call today. I see we have a very large group, and I will walk through several parts of the slides and give you an outline of what our presentation is today. And this is an inaugural event because this is the first Think-a-Thon. And I very much appreciate the interest and am enthusiastic about the idea that so many of you are interested in using data science for social science research. So ScHARe is next slide. Luca, next slide. ScHARe stands for the Science Collaborative for Health Disparities and Artificial Intelligence Bias Reduction. Next slide. It is actually a collaboration between NIMHD, the National Institute of Minority Health and Health Disparities, the Office of Data Science Strategy, which is an office of OD, of the Office of the Director of NIH, and the National Institute of Nursing Research. Next. I want to especially thank the key people in making both ScHARe possible and our very first Think-a-Thon. Of course, I need to thank our director, Dr. Alison Perez-Stable, the director of ODSS, Dr. Susan Gregrick, and the director of NIH OD, Larry Tabak. In order to make this happen, we had to work with several people. I want to acknowledge our Office of Communication, the RLA contractors, BioTeam Strides, the Terra platform, CITEM, and we actually have a working group at NIH in which we are developing core common data elements, which you will hear about later. Next. So the outline for today is we're going to give you an introduction. This is going to be an overview. We're going to talk about ScHARe and the Think-a-Thons. We're going to do artificial intelligence and computing concepts behind ScHARe, because I would imagine that there are diverse perspectives and learning levels. So we're going to try to do something for every learning level. And this is exactly why the purpose of ScHARe is, so that we can start from ground zero and not use a lot of jargon, but for the expert side to make sure that we have all the pieces that you need to do cloud computing research. We'll have some interactive exercises, both polls and the use of whiteboards. And we have two guest speakers today, Lakshmi Matukumalli, who is an Idea States program director. Idea States, for those of you who don't know, are made up mostly of minority-serving institutions who are also adopting cloud computing. And we'll also have a guest speaker, Alison, who will talk about the ODSS training opportunities. Next. Now I'd like to introduce Kevin. He will talk through how to do the polls and how to do Slido, because we're going to be using both of those today. Kevin?
Thank you, Dr. Duran. Just a few quick housekeeping notes. For the majority of today's Think-a-Thon, please make sure that your camera is off and your audio is muted. If you do have questions during the presentation, please use Zoom's chat feature. We'll get to as many of these questions as we can during the Think-a-Thon. And for the sake of everyone participating in today's Think-a-Thon, if your audio is unmuted when it should not be, and we do start to get feedback or background noise, event staff will mute your line. So today's Think-a-Thon will feature some interactive polling and ideas using an application called Slido. And so now I'm going to quickly give you a rundown of what that looks like. And so To use Slido, first of all, you can either download the Slido app on your phone or simply go to slido.com on your phone or your computer. So when we get to those polls, at this point, you can feel free to go to slido.com or again, download that Slido app on your phone.
And we're gonna pause just a minute for you guys to sign on and do this.
So once you're able to go to slido.com, as you see on the screen here, you will enter the code TAT01, that's Think-a-Thon 01. So TAT01, where it prompts you to enter code here. For those of you who go to slido.com, that box to enter your code will be at the top of the page. It will be a blue box as it is shown here on the screen. Also, you can scan that QR code that is showing here now on your phone, and that will bring you right to the Slido application for this Think-a-Thon. And so with that quick explanation, I will turn it back to Dr. Duran.
I am just going to take a pause and let you guys sign into this so that you are ready to go. And Kevin, will you put the www.slido.com link into the chat, please?
Absolutely. I'll have our event staff type that right into the chat right now. Again, it's just slido.com.
Okay. So, Luca, go back to the slides, please.
Should I advance the slides?
We can't see the slides.
Let me share the screen again.
Kevin, do you have to unshare?
Nope, you should be able to share.
Next slide. Oh, I'm sorry. So the very first sort of poll we want to get from you is what is your current experience? So Kevin, can you put the poll up, please?
So again, at this point, everyone should be on slido.com. Type in that code TAT01 and fill in the poll that is currently showing on Slido.
If you have any trouble getting there, please just put in the chat and someone will help you.
Yep, we are seeing votes come in, so thank you all for that. We're almost at 100 people who have voted at this point, so thank you everyone. But like Dr. Duran said, please feel free to let us know if you're having any issues. For many people, the easiest way is to just take your phone, scan that QR code, and it will bring you right to the survey. Now up over 100 responses, so thank you everyone.
Okay, Kevin,
Dr.
can you
Yep.
give us a tally? We got over 100 here. So good. Some looks like some have. Good. So we have some experience, but not a lot, which is good because this is really trying to gear to get you more experience. So thank you for the first poll.
This is experience with R.
R. Oh, there's a lot of people without cloud computing experience. So this is going to be perfect for you all. And also no experience with Terra. So this is also, this ScHARe platform is going to be very good for you. And I'm excited to see that it's health disparity researchers also involved, because this is one of the intents of ScHARe. Very good. So it looks like we have good outcomes researchers as well. And no experience with, or little experience with bias mitigation. So you all have come to the right place to get the experience with Terra, cloud computing, bias mitigation. Thank you, Kevin. Luca? Next slide. Today, I will be presenting part of this, and Dr. Calzoni is going to present the other part. Next. So what ScHARe is, it's a cloud-based platform. It's actually focused on social science data. For those of you with experience at NIH, most of the data is basic science, genomic data. This is the first data set that is really focused on the social science part. And one of the reasons that we wanted to do this is so that we have a centralized place where social science data sets are, and that we can bring together and collaborate research using these types of methods in a secure setting. So the cloud platform actually provides a secure setting. Next. We're trying to fill 3 critical gaps at NIH. One of them is to increase the participation of women and underrepresented populations within data science. The other is to increase research opportunities afforded by big data and cloud computing to the field of health disparities research. And then, of course, to advance bias mitigation and ethical inquiry in the types of machine learning and AI that are already being produced. And we're seeing many unintended harms done with AI. Next. As I said, our mission is the data sets. One of the things that we're also doing with this is we're creating an ecosystem, and that we will explain this a little bit later. It's going to be a platform where you can combine federated data or national data sets with our project data so that everything is in one location. Next. As you can see on the right, these are the components. So in the ScHARe cloud platform, it's a secure workspace. It has federated data sets. For those of you who don't know the term, it means these are national data sets in which private information has already been cleaned out. It would be information like mortality tables. We'll have hosted data sets. So in a cloud, and Luca will explain this later, some data sets are hosted already by a cloud, and some we have to put in. And so an example of a hosted data set is Burfus. So we have the behavioral data set. We'll also have a data repository where we can put in our project data, any grant project data, especially using social science types of methodologies and data can be included. And of course, we have a ScHARe web portal that is on the NIMHD webpage. And we're using these think-a-thons as a way to help increase the knowledge as well as to provide research collaboration teams. We are also using a Terra interface, GitHub, and a Google platform. Next. It is an ecosystem. That means we're going to combine all of these things together. So you're going to be able to move from one thing to another with a click rather than having to write code. And that's very important because one of the things that has made cloud computing difficult is that any of you know it, you have to know Python in order to do it. But we're trying to do this in a way that you actually can do it with clicks and drags. Next. As you can see here, if you see the little bar to the left, these are the categories of the data sets that we have: disease and conditions, economic stability, education access and quality, health behaviors, healthcare access and quality, those that fall into multiple categories, neighborhood and built environments, and social and community contexts. Some of these data sets also cross multiple years. Next. When we are completed the first phase, we're going into the second phase now. So the data repository part of the ScHARe is not built, but I just want to highlight it is that ecosystem that will allow the data sets to cross over. So as you can see, you can map to the data sets. And this is a feature that has never been done before. We're going to be able to map across platforms. And Luca will explain that a little bit later. And the other platforms are things like Anvil, Biodata Catalyst, Anvil, and some of the other clouds. Next. In the ScHARe Think-a-Thons, we really tried to develop ScHARe to meet all the needs that were missing, from cost to collaborations and knowledge about cloud computing. So we are trying to start from basic data science language to show you how to integrate this into health disparities research and be able to benefit from it, from large data sets and the information that can be gleaned from our research. Next. And one of the tools or the ways that we're going to do this is to actually conduct monthly think-a-thons. There's going to be two different types. The first sort of set of think-a-thons, like this one, is more instructional. And then the second set of think-a-thons are actually going to be research teams. And we hope that the research teams will be from students to senior investigators that come together to use the platform to solve or create hypotheses using big data and actually work together to complete a study and a publication. This is also an opportunity we're envisioning for networking and for mentoring and coaching, what I call up and down. So I would imagine many of the younger involved data scientists will help teach some of us older researchers how to use data science in the cloud more efficiently. Next. So we have an interest poll now. Kevin, if you want to take that over. And we'd like you to check all of that apply of what you are interested in. So please go to your slide up. It's fun watching these, isn't it? Okay, we have quite a few votes in, and it seems like many people are actually interested in doing the research aspect. And the bias mitigation tools are also very important. So this gives me great enthusiasm and hope, because this is exactly what we are trying to do with this platform. I'm now going to turn the mic over to Luca, and he's going to do first sort of an overview of big data and cloud computing, and then he's going to move into more detail of the components of the ScHARe platform.
Hello, everyone. My name is Luca Calzoni. I'm a physician and data scientist at NIH, and I've been working on the ScHARe project since the very beginning, so I'm very excited to be here today. I'm going to introduce you to some of the basic artificial intelligence and cloud computing concepts behind our platform, ScHARe. And I'll start with the easiest one, big data. So big data, of course, is about large data sets that are analyzed to gain detailed insights. And to do that, you often need AI and substantial computer processing power. And these data sets can be linked together, can be merged across different sources. They may contain structured or unstructured data. And we talk about fair data when these data sets meet certain principles of findability, accessibility, interoperability, and reusability, which are important to make them computable and machine actionable. The good news about ScHARe is that by obtaining access to the ScHARe data ecosystem, you will have access to more than 300 datasets eventually. And I'll give you some examples of the datasets that will be included. So the American Community Survey is one, or US Census, or Food Access Research Atlas, or the National Environmental Public Health Tracking Network data, or as Dr. Duran said, the Behavioral Risk Factor Surveillance System. And I said that to analyze big data, substantial computing power is usually required. And that introduces the concept of cloud computing. So in the past, data storage and processing used to take place on your personal computer or local servers. But in recent years, they have migrated to digital servers, which are operated by internet platforms. So researchers can now access, store, and process information remotely. And this is very convenient, of course. It's also reliable, and it also offers you the ability to scale applications quickly, depending on your needs, and to pay for the costs accordingly. So we have three main public cloud service providers, which are Google, Azure, and AWS. And ScHARe uses Google. And the good thing about ScHARe is that it offers computing environments that can be customized or also standardized if you want to make sure that everyone in your research group is using the same software to conduct the same analysis. And there are ways to do that using a custom Docker image or a startup script. So I said that ScHARe uses Google. So Google Cloud Platform is a provider of computing resources for developing and operating web applications. So it provides a series of management tools and a series of services, cloud services, including storage, analytics, machine learning, and computing. And through Google, our platform offers several things. So access to BigQuery and TensorFlow for advanced machine learning, as the more experienced users among you will know. And it offers access also to the datasets that are included in the Google Cloud Public Datasets program, such as ACS, US Census. These are datasets that are hosted by Google, and they are made accessible through BigQuery from ScHARe. And also, having chosen Google means that each one of you will have $300 in user credits, in free credits to cover your initial computing costs. And of course, a Google email address will be needed to register for ScHARe and to access these benefits. So AI. AI is defined as machines that respond consistently with traditional responses from humans. So meaning that they are intentional answers, they are intelligent answers, and they are answers that have adaptability. So these systems, AI systems, can learn from data, text, images, and make intelligent decisions, intentional decisions based on that analysis. And the good news, again, is that ScHARe will support AI tools in your AI activities and tasks. So many AI projects are built using Python, programming language, and ScHARe fully supports the Python libraries that are most commonly used for these kind of tasks. And we'll get into more detail, of course, in the next Think-a-Thons. Among AI tools, I'd like to mention data mining. So data mining is a series of techniques that analyze data to gain insights. And for organizations, this means getting insights to improve their processes. For researchers and research institutions, it means being able to identify those associations and correlations that help you answer novel research questions. And I'm saying novel because that's what we want to do with ScHARe. So we want to enable a research paradigm shift. So to leverage big data and AI tools to develop more innovative research questions and projects. So data mining involves use of algorithms, so software-based coding programs, as you all know, especially machine learning, rather than the traditional statistics. And there are several kinds of data mining, and machine learning in particular is based on algorithms that can learn from data without being provided labels or relying on rules-based programming. So it's basically a way for these tools to classify data or objects without receiving instructions. So the algorithm learns in the process and applies what it learned to new classifications in the future. And again, I have good news for you. So ScHARe will support your machine learning work. So there are tutorials on the platform that will show you how to scale and manage model training and serving. There are several ways to do that with internal notebooks. I will explain that in the next Think-a-Thons, or leveraging Google Cloud Platform's Vertex AI. And this is probably more for expert users, but novice users will also find the resources they need to help them move their first steps in the machine learning world. And we are at neural networks. So researchers use software to perform some tasks by analyzing training examples. So it works similarly to the neural nodes of the brain. Neural networks learn in layers, and they build complex concepts out of simpler ones, and they apply those concepts to the next layers. And there are so many applications. So deep learning is actually used for driverless cars or in genomics or to discover new drugs. And so basically, deep learning uses statistics to spot trends, patterns in the data, correlations, and to apply that knowledge to the other subsequent layers of analysis. So again, it's a way to learn by example. And once again, requires labeled data and extensive computing power. And the problem with AI is that these algorithms are widely used in healthcare and policy decisions, but many operate as black boxes. So they're not transparent. They offer little opportunity to be tested for potential biases. And biases occur pretty frequently, actually, because they can result from so many things. So from social or cultural context that has not been considered when designing the algorithms, so other design limitations, or they can also result from problems in the data, such as data missingness or other data quality problems, or they could be tied to the algorithm development process or to the training of the model, which hasn't been done correctly. And the problem with bias is that if we don't identify these biases, these bias algorithms can lead to decisions that can lead to discrimination, inequitable healthcare, and health disparities. And this is why we are building ScHARe, because we think that critical thinking and like a critical approach to AI, and most of all, diverse perspective are needed to mitigate biases. And we know that populations with health disparities are traditionally underrepresented in data science. And so that's why this is particularly important. And we are envisioning a platform where you can come to collaboratively develop bias mitigation tools and strategies, because that's one of our main goals. And I'll close this section by mentioning ethical AI and explainable AI. So it is really essential that algorithms respect those basic human values such as security, safety, privacy, accountability, most of all, and transparency. And one way to do this is to promote explainable AI. So as I said, one of the problems with AI is the lack of transparency, right? So what happens is that developers often don't indicate which data they use to train the algorithms, or how they weigh the different factors that are involved. And this results in a situation where from the outside, you cannot tell actually how the instrument has reached the decision that it did. And this lack of transparency leads to mistrust in AI. So explainable AI is a field that tries to describe the function of AI or the specific way it reaches decisions by providing more transparency into the decision process to make AI more understandable and ultimately trustworthy. So in this section, I would like now to transition to the benefits and challenges that are tied to the adoption of artificial intelligence and cloud computing. And as we know, and as we have seen, they are revolutionary technologies with so many benefits, but also with so many risks and challenges. And before we discuss those, I'd like to hear from you. What do you think, and what are you experiencing in your personal research work, if you have already adopted AI or cloud computing, or what you are anticipating, if that's a step you want to take in the near future, to be the benefits for you, for your research work of adopting AI and cloud computing. So I'm going to ask Kevin to please take over and display the whiteboard that we have prepared. And I'm going to ask you to use Slido to input the concepts that come to your mind in terms of benefits of AI and cloud computing adoption. And we'll dedicate a couple of minutes to this so that
and the potential use of big data.
Perfect.
Yeah. So please type in your Slido.
Perfect. And as the ideas start to come in here, you will be able to, in your Slido, upvote the ideas that you think are good ones. So feel free to upvote any ideas that you see that you agree with.
And when he means upvote, that means that you see the little thumb on the side. You can click the thumb as up, and the more people that click on it, the more idea will get attention.
And I already see many interesting suggestions. So easy access to data, support for decision-making in the medical field, or more resources to achieve high predictive power. That's true.
I especially like the one on disparities for smaller, vulnerable populations, because that's always been a problem.
And And just a reminder that with so many ideas coming in, you may need to scroll down the page to view some of the more recent ones.
And help identify the issues and develop solutions for populations impacted by disparities. Allow researchers at non-research-based institutions to have a greater level of participation in research. Find connection in the data that I would have seen or thought of. Yes, definitely. Reveal the insights that were not published in the past on the same note. Collecting and analyzing community input, sharing knowledge, new discoveries.
I also like the new scientific discoveries, because one of the things that we find in big data is that the data itself reveals patterns and mechanisms that we never even thought of before. And we see that evidenced in genomic research.
And I also like that collaboration is mentioned. So getting the right data sets and collaborate with others and learn how to use the tools. That's exactly one of our goals with ScHARe. And something that cloud computing makes possible across disciplines, even.
I also see mitigating harm and improving treatment interventions. And this is another sort of goal of using big data, is that you have that better understanding of intervention points.
And rare condition research. I like that too as a physician. Improve patient outcomes for vulnerable populations. Answering more precise research questions. So new innovative research questions. I agree. More transparency, more reproducibility.
And actually, there's one that says identify the gaps in data. That's actually very important as well, because when you're able to centralize data systems, you can actually see what is missing. So that is actually a very important part of big data. By your responses, I'm very excited, because it seems that you all are on the same page that we are in advancing both ScHARe and the Think-a-Thons. And this is what many of these things are what we hope to achieve, not only on the ScHARe platform, but through doing the Think-a-Thons, especially when we get into the research sections of the Think-a-Thons.
And some of you said less dark data. I like that too.
Oh, yes.
Data is not used.
Yes, because we have a lot of dark data. And for those of you who are new, dark data is the data that is collected but never used. And so by having platforms like this, we can start using data that we collect, because we collect so much data and only about a third of the data is ever used. These kind of platforms actually allow us to use more of the data that is collected. So I'm very excited by all of your responses, and we're going to save all of these because these are going to be our guiding lights, and we're going to move to the next section because of time. Okay.
Yes. Okay, very interesting. Okay, so let's see some of these benefits. Let's see if they coincide with the ones that you provided. So access to big data sets and large data ecosystems is one of the main benefits, right? So there's such a variety of data, so such expansive data sets and varied data sets right now. And there are vast repositories that the cloud enables you to map and link. And again, this is exactly what ScHARe wants to do. So by giving you access to those data sets, so the Google Cloud public data sets, the ScHARe hosted public data sets, and also the funded data sets on ScHARe, which, by the way, will allow users to comply with the NIH data sharing policy. That's exactly what we want to do, give you access to more data in an easy way, because this data is usually sparse and difficult to find. And we want to build this centralized place where you'll be able to come and find all the resources that you need, both in terms of computing power and of data. And the data sets on the platform are actually categorized based on the CDC social determinants of health categories. So economic stability, education access and quality, healthcare access and quality, neighborhood and built environment, social and community context. And we added 2 more categories: health behaviors and diseases and conditions. And again, when the platform will be fully implemented, you'll be able to map and link across data sets, which is pretty innovative. And another benefit is deeper insights and better decision making. So being able to identify trends in large data sets with more accuracy and in a quicker way. So of course, AI also facilitates decision making, especially in the clinical setting or in policy applications. And AI does this thanks to machine learning and data mining mainly, right? And this is a true revolution in terms of productivity, efficiency in the research world, and insights gainable leveraging big data. And again, the good news is that all of this is supported by ScHARe. So ScHARe will support your machine learning-based analysis, and tutorials will show you how to perform those tasks. And then another benefit is intelligent automation and data management. So as we know, AI deals with massive amounts of data, right? And it can do that in a programmed manner with little human intervention. So there are those automated repetitive tasks, data management tasks especially, and AI can help do those and take some work off of you. And ScHARe in particular has workflows and pipelines. As you all know, pipelines are a series of steps that are usually performed by a compute engine for bulk analysis. And ScHARe uses this thing called workflow description language, which is a language easy for humans to read, to do those operations automatically, so for batch processing data. And we will also have SAS integration planned to help the users that are more familiar with SAS and other statistical software. Here you can see a screenshot, by the way, of how the workflows look on the platform. Real-time collaboration, this was also mentioned among your responses. So the cloud enables truly collaborative work, and it brings together researchers from different locations and, most importantly, across different disciplines, enabling true discoveries. And ScHARe will enable collaborative teams that will come together to collaborate, share data, analysis, and results with their collaborators in real time. And they will design also innovative research projects, leveraging big data and AI tools. So you see that this is a screenshot from the platform where you can see a Jupyter Notebook, which is basically a document that contains live code and executable cells. You can use Jupyter Notebooks to outline your analysis and actually perform the computations and work collaboratively with your collaborators and colleagues and share the analysis and the results once your research work is completed or along the process. Increased security. That's another benefit. So there is sensitive data in the cloud, of course, but there are network security tools that track network traffic. They can detect anomalies and they can solve them.
Sure.
And ScHARe provides researchers with secure workspaces that they can share with their collaborators. And in terms of security, the platform is secured according to the best practices in information security. So it's authorized to operate as FISMA moderate system, and it's FedRAMP authorized for those of you that are more familiar with these terms. Another benefit, lower costs, because using the cloud reduces your upfront costs because you don't have to deal with on-site data centers and so hardware maintenance costs, etc. So all those costs are eliminated. And staff costs are also reduced because, as we said, AI tools can gain those insights with little human intervention. And in building ScHARe, we adopted a low-cost approach. So we try to use as much as possible low-cost and open-source components. So the Terra platform, GitHub, open-source libraries, to keep platform costs at a minimum and to pave the way for the adoption of similar initiatives by minority-serving institutions, especially. Challenges. So there are many challenges. I'm sorry?
Kevin, will you please mute people?
Yep, we are. Thank you.
Okay, perfect. Thank you, Kevin. So what are the challenges that complicate the adoption of AI in cloud computing? So one of the main challenges that is always cited is lack of knowledge and expertise. So research institutions are finding it really hard to find the talent and to find professionals that have the required skills and know how to use AI in cloud computing. And this is why, one of the reasons why ScHARe was born. ScHARe provides step-by-step guides, tutorials, training materials to help not only advanced users, but also novice users accomplish their research goals and upskill. That's a term that we really like. So upskill their careers by acquiring this kind of experience. Another challenge, data privacy and security, or I should probably say misperceptions regarding data privacy and security, because as we have seen, the cloud is actually more secure than your local system, than your local computer. And of course, this means that using the cloud means that institutions need to create privacy policies and make sure that all data is secured when using AI in the cloud. But and it's also true that not all cloud providers can assure like 100% protection, 100% data privacy. But in choosing our provider, we chose the Terra platform, which is the platform powering ScHARe, and it's powered by Google. And of course, the provider we chose uses best practices and industry standards. So it's compliant with all the most commonly accepted security and privacy frameworks. And we are also working to get single sign-on using RAS in the near future. Another challenge, performance, reliability, and availability. So of course, if the cloud vendor is affected by reliability or performance issues, so would be the organizations that use their services. That's a given. But again, choosing the right cloud service provider means that that provider will have real-time monitoring policies that will make this less likely to happen. Another challenge, I cannot not mention bias. So the widespread use of AI raises all sorts of ethical, moral, and legal issues. So as we said, AI biases are found everywhere. So in the data, in the algorithm design, in the implementation phase. And one of the main problems with this is that populations with health disparities, so the populations that are mostly affected by this, are also underrepresented in data science. And again, that's why we are building ScHARe. So we need these populations with health disparities to be more represented in data science. We need to promote the identification of bias mitigation strategies. And we need to create this critical approach to AI that will make it possible to reduce these biases, even if they probably will never be eliminated completely, but they can be reduced. I'd like now to hear from you. So, Kevin, if you can take over, I'd like to hear about what challenges are you experiencing in your personal research work, or you are anticipating if you haven't adopted AI and cloud computing yet. So it's going to work like the previous whiteboard. I'm going to ask you to please mention all the challenges that you are encountering in adopting AI and cloud computing.
So you also understand in this section, we have actually 4 different whiteboards. So the first whiteboard is going to be cost. So what are some of your concerns and challenges related to cost? So only focus on cost on this one. And again, use your Slido. It would help us if you were more specific about cost. Do you mean the cost of hosting a data set? Do you mean the cost of running analysis? It helps if you give us a little more specific information about the cost concerns. Again, in the chat is the Slido with the code.
So we have prepared 3 whiteboards with the most commonly identified challenges. So the first one is going to be cost. The second one is going to be lack of training and experience. The third one is going to be about research applications and the difficulty in identifying those research applications in for AI and cloud computing. And then we'll have a final whiteboard for all other challenges that you may be experiencing. So please focus on costs only for this one.
And the cost can include infrastructure costs as well as analytic computing cost. Okay, it looks like it slowed down. So let's go to the next whiteboard, please, Kevin. And this focus on the challenges of knowledge and training. And it would help if you started, again, be more specific about, needing training using data science, using Python, using R. I like the one with so much lingo, hard to keep up. That's the way I felt for 2 years.
I was going to say the same. Very limited training, deep learning curve. Sustainable training for staff with turnover. Training with Python and R. Yeah, I agree. Need resources to understand these terms conceptually, since many focus on the technical aspects. But sometimes these concepts are hard to grasp. Very interesting.
Yeah, these are some of the challenges that we have tried to address with the development of ScHARe.
Yes. And I show you how in a minute.
We will keep all of these as a resource so that as we move further in and we develop more aspects of ScHARe, we want to make sure that it addresses most of these challenges, because we want to be sure that you have the lingo, that you have the training, that you're able to have access to the data sets, and that you're able to utilize big data in health disparities and health outcomes research that we, as underrepresented, I mean, if you can see what this has done for like genomics, it's transformed the field and drug development. We can do the same thing with health disparities and health outcomes. So we're going to invest a lot of our energy in addressing many of these challenges. Can you do the next one, please, Kevin, on research applications. So in this, what do you think would be some research questions that big data could answer? Not like a project data, but big data, so that you can combine many data sets together. How would you rethink the research questions you would ask?
Identification of social needs with big picture of seemingly unrelated factors. I like that.
I like the more focus on confounders as well, because that is a very interesting part that big data can actually help address.
Rare diseases.
And as more responses come in, don't forget to use those thumbs up buttons to upvote the ones you like. And don't forget, you may need to scroll down the page to see all the responses.
I love exploration of genetic markers for certain diseases in marginalized populations, because that's actually one of the collaborations that will be hopefully made possible by the platform.
And to piggyback on what Luca just said, it is actually one of the aspects we're doing in the second phase, so that we can connect ScHARe to Anvil, which is the genetics database that ScHARe cloud platform. So it seems as if you all are envisioning how big data can help us move the field of health disparities, health outcomes, and health of minority populations forward. So this is a very exciting, and I am enthusiastically assured that we will be able to do this together using both ScHARe and the cloud platform. So I wanted to give this last slide for any other input that you wanted to add as challenges to adopting the cloud, besides cost, training knowledge, and understanding sort of a bigger picture research question. So please add any other challenges now that was not added before. I like the knowledge hoarding.
Yeah. And the availability of data too. Ethical issues, mistrust, lack of AI from more experienced disparities researchers.
As we move in further development, we're going to invest some energy really in the ethical aspects of AI and bias mitigation. So stay tuned. And if you have not already signed up for the ScHARe email listserv, please do so that we can keep you informed about our upcoming activities, especially related to the research and bias mitigation. All right,
It's
so
the-
we're gonna keep all of these as well to make sure that we use this information for future. And Luca, if you continue, please.
Sure. Perfect. So I had anticipated some of your answers. And so the purpose of the next slides is to show you how we are trying to address those main challenges that you highlighted. So one of the challenges was cost. And as I said, we are trying to develop the platform using a low-cost approach, using open source components to keep platform costs at a minimum. And you can see in the screenshot on the left that the costs to actually run the cloud computing costs involved, etc., are really minimal. And of course, this is going to vary depending on your needs, depending on the applications, etc. But the cost can be minimal. In terms of lack of training and lack of knowledge, we are trying to address that in many ways. So we are providing step-by-step notebooks for novice users. So you can actually see a screenshot of the platform. You can notice that there are several tabs on the top, right? So dashboard, data, analysis. In the analysis section, you can see the notebooks that we have prepared. It's a series of instructional notebooks that provide you with step-by-step instructions that show you how to access data, prepare the environment, access data, plot data, save the results to your computer, etc. And we try to make those really understandable, really easy to complete. So that's a good starting point for those users that are less familiar with AI and cloud computing. Another step that we took was to host this page on our website. It contains an updated list of free tutorials, e-learning resources, right? This is on the NIH web portal. You can check it out. The address is actually on the bottom right of the page. And it's going to be updated continually as we find new resources and new things that we think might be helpful. And another instrument, of course, is the Think-a-Thons. So the Think-a-Thons will be used to share knowledge. And as Dr. Duran said, in the second phase, to form research groups around innovative research collaboration projects. And hopefully this will also lead to publications, because that's our goal, to advance knowledge and to publish our results. And then training opportunities through the NIH STRIDES initiative. So you can actually check out the website, cloud.nih.gov training, and you'll find many training opportunities that might be accessible to you for free, and they're really helpful. In terms of possible research applications, I thought I'd provide some examples of things that can be realized thanks to the cloud. And I want to give you an example of research collaboration using the cloud, citing N3C. So N3C is the National COVID Cohort Collaborative. It's basically a cloud portal hosted by NCATS. And we plan to follow a model similar to N3C with ScHARe. So N3C is organized in domain teams. So researchers across disciplines or with shared interests come together to collaborate in groups to analyze the data that is made available in this cloud. And you can see an example of data that was analyzed to answer some of the research questions that you see on the right. So we were studying actually the impact of the social determinants of health on COVID-19 morbidity and mortality. So finding associations between the social determinants of health, shelter-in-place policies, or vulnerability and resilience to COVID-19 for each race ethnicity. But the details are not important. The thing is that this was made possible by online collaboration. And again, our Think-a-Thons will promote the same thing. So the formation of these groups around shared interests. And I thought I'd provide some examples of possible projects. So we could explore the impact of individual or structural social determinants of health on health outcomes using the data sets that are available on the platform. Or we could study how non-clinical factors impact disparities in healthcare delivery, for example. and we can come up with good ideas together in the second phase.
So we're close to running out of time. So Luca, these slides will actually be posted about a week afterwards. So if you can go just really quickly through, and then we're going to turn it over to Lakshmi. So we're just going to click through the slides to just show you. Go, Luca.
Sure. I wanted
Click,
to show you this.
Just click, please.
Yes, the potential for collaborations that ScHARe has. So NIH is a series
Luca,
of...
please just click through these slides. Click.
Oh, okay, sorry.
So we have strides. Click, please. There's also initiatives, Aim Ahead and Bridge to AI. You can see the slides and look for them later. Next, please. All of Us, Anvil, Biodata Catalyst. These also use the Terra platform, which we will be able to collaborate with in the future across platforms, which is going to be very unique. Click, please. And this shows how we can all formulate together. Click, please. Click again, please. And again, please. And so we want to introduce Lakshmi. He is the NIGMS idea. So if you can please take over, Luca will run the slides for you, okay? Next, Luca. You're on mute.
Okay.
There you go.
Okay, great. Thank you so much. Again, I appreciate the opportunity provided by Luca and Deborah to present to you at this inaugural session for launching during the launch event of the ScHARe program. Again, my name is Lakshmi Matukumalli. I am a program officer in NIGMS. So I'm going to talk to you about some of the efforts NIGMS is doing that is synergistic to some of the other NIH efforts in the cloud computing space. So next slide, please. So, our association with the NIMHD started with a couple of years ago, where we conducted a workshop. It was a joint workshop conducted by NIMHD, NIGMS, ODSS, and CIT all came together and wanted to explore the space of the cloud computing and its usage in the biomedical research. So what we observed was most of the RCMIs, the minority serving institutions, and also the network institutions in idea states, they don't have access to the high performance computing. So what we thought was like the cloud computing as a way to democratize the computing so that everyone can have access to the high performance computing that the cloud can offer. So the workshop videos and all are available in the website I have provided here. Next slide, please. Similar to the discussions we are having, we also had the discussions and talked about what are the challenges, what are the opportunities of the cloud computing. So, again, some of the topics that came out was there need to be better understanding of the cloud computing. There need to be a lot of training. And also there are several opportunities that the participants have identified. So you can see that the cloud computing has the ability to enhance collaborations, data reuse, software sharing. It can contribute to research reproducibility and so forth. So I think my presentation is going to be focused on towards the challenges part of it. So that's the training part of it. I think again, the opportunities in this space for the social science research especially is very well addressed through this ScHARe platform. Next slide, please. So along the lines of what Deborah and Luca have mentioned, so we have collaborated with the STRIDES program, and provided training to this lot of this people or the researchers within the IDS team. So we have conducted the beginner level, intermediate level, and also advanced level courses, both in Google Cloud and AWS. So we conducted about 48 classes. There were about 500 participants from 19 institutions that have participated in this effort and got benefited about learning about what the cloud computing is. Next slide. So I want to now share a success story of how cloud computing was used to eliminate a bottleneck. So in 2021, we funded a new IDEA National Resource Center for Quantitative Proteomics. So on the left, you can see the workflow of to produce this mass spec. These are all several mass spec machines that we were able to fund. So those are the workflows about how to analyze the tissue samples and do the experimental data part of it. And then the next part is the data analysis. So it was generating, previous slide, it was generating huge amounts of data, and the bottleneck was they didn't have the computational power to be able to process that all their data that is coming from, and also a way to deliver the data. Next slide. So what we did was we got in touch with them through the Google Professional Services. So we gave a contract to Google Professional Services to help the researchers to lift and shift the projects. Basically, what they were doing is using the local computing. So all the data flows have been shifted into the clouds. So the outcome of that was the UMS. They now own a GCP account, and then they launched a new system in early 2022. So basically, now they have all the processes now working on the cloud instead of the local machines. So now all the project delivery, the data sets, the single link, they can get the data sets, the results, and then in terms of the data analysis, so it's now 5 times more effective and also 6 times more faster. So they're able to leverage the flexibility of using the data in the cloud. So again, you can see the comment here from the PI for that. So this is just I want to share an example of how we have used the cloud. So the next one, next slide, please. The next one, I want to talk a little bit broadly about the use of this cloud computing platform. So the NIH, we saw that we have different ICs have adopted different cloud platforms, and that is also for the specific for their community. So if you say, for example, you see on the left, so there is a National Cancer Institute. They have initiated this cancer research data commons. So if you want to analyze all the cancer research data, so you can go into that portal. So you have all the data there, and also that you have the tools to do that analysis. So they're bringing the data and the tools together to do that. Similarly, the Anvil platform is bringing together the genomics data. So now you have seen the example of the ScHARe platform that is bringing up the social determinants of health. So primarily these are using platforms called either 7bridges or Terra to enable the cloud computing journey. So if you think more broadly, so this is I'm showing it, you have a destination A to destination B. So, you are looking at, you want to make a journey between these two, you have a goal to analyze the data or solve a biomedical research problem. So these are, makes your life very easy by, making it very easy for you to, make this journey. So next slide. So what NIGMS is doing a little different. So we are basically, we train high schoolers to undergraduate to graduate students, junior researchers, postdocs, all of them as to how to, conduct like the biomedical research. So this is we're training the next generation of workforce. So in this process, so our main focus in the cloud, as I said, as complements the other IC efforts, is to teach more about the cloud journey. So for example, when you are doing those platforms, you're not focusing on the cloud itself. So you are focusing more about like what data sets are there, what tools are there. So here in this, like we are putting a little bit more focus on the cloud platform itself. So how if you have got like this, I'm showing two different platforms. So this is the top one is the Google Cloud Platform. The bottom one is AWS. So if you go in and to the Cloud Console, so you see this, like, and then on the left, you see numerous tools that are available to do that, like a different data analysis, how to store, how to instantiate a virtual server, and so forth. So we are thinking about more holistic training, but also like a little bit on the more basic side of things, so that once you know how to do it, like I think once you know driving, you can travel anywhere. So that's the concept behind the strategy that we have taken for in the cloud computing. So next slide, please. So in that way, so we have started building called sandbox module. So here, what I'm showing in the map or called the idea states, we have 23 idea states that are shown here. So these are usually the states that receive least amount of the biomedical research funding. So we wanted to increase the biomedical research capacity in these states. So that's the objective there. So we have the program to do that. So now in 2021, we have developed two projects as pilots. So one is the RNA-seq and then the proteomics. So these two projects were developed as a pilots to show kind of like we funded a couple of researchers from Maine, University of Maine and UAMS to develop these modules. So what we did was we have taken a Google PSO contract, and we asked the Google and Deloitte researchers to help these researchers develop these workflows in the cloud. So they have developed workflows, and as a result, they have developed these modules. So in the last year, we have expanded the efforts to build another 10 new modules. So basically, it involves a lot of train the trainer approach. So these researchers were trained on cloud computing. They were trained on developing the workflows, use Jupyter notebooks and source repositories, quizzes and visualizations. Next slide, please. So again, this is kind of, these researchers were primarily earlier doing their, computational analysis in the local computers. So they have converted them into the cloud. Now you can see the cloud-based workflow that's created. Next slide, please. So again, this cloud modules have different features. It have an interesting a video with an interesting story, README instructions, quizzes, graphs, visualizations, workflows, the practicum data sets. Next slide, please. So this is going to be the 12 modules that are going to be coming out from this effort. So this is a work in progress. So they're still developing these modules. So they will be ready around mid of this summer. Sometime like we'll be releasing next. So the way that we think about this is a sandbox is like these are play toys that you can work in that cloud environment, so that like you will be able to use this as a toys to learn about computing. So again, the primary focus, you can see that there are some artificial intelligence, machine learning, a lot of omics analysis. So use this for your learning journey. Next slide. Next one. So just as a the CIT is developing a platform called Cloud Lab. So the idea behind that is like to make the cloud accessible to all the users. So basically, they're going to provide you free credits to get into next slide. Next. It will provide you basically the cloud console. It's either AWS or Google Cloud Console. And so from that, you can next one, and next one. So you can, run these sandbox modules in the native cloud environment. So and then learn how to, do that. So then this will be available in 3 different platforms. So next one. So this will be available in Amazon, Google, and as well as Azure. So you can think about working in the native and cloud environment, understanding how the whole of this cloud environment works from that perspective, and then learning to run some of these basic bioinformatics data analysis modules, so that you can be sure that when you're ready for your cloud journey, I think this amazing interfaces that all these other ICs are building. So I think this is going to greatly complement those efforts. So I think that's what I have. Next slide. With that, I will take any questions.
So if you have any questions for Lakshmi or for us, Kevin, can you please unmute people now so that they can use their own mute to unmute themselves for questions?
Yeah, folks should be able to unmute themselves.
Okay.
Currently.
Is there any questions from anyone to us, to Lakshmi?
So, yeah, I see it.
There's one question that says, what is the capacity of your sandbox?
Yeah, so the first question was about how to set up the sandbox, so that I think this is going to be part of the instructions that we're going to provide as a part of that. How to basically you get a Cloud Lab account, so that is a cloud account. So now from that you will be able to launch these modules, so that you can teach yourself as to how to initiate these each of these different modules. So there is I think it is a cloud. Cloud has infinite capacity, in the sense you can do a lot of things. You can basically it's your purse kind of how much you can pay, because it is elastic and expandable. But right now we'll have full modules where you can you'll be able to test these modules, or run these modules, learn from that. Unless there's other way of looking at your capacity there, I don't understand. But
so Lakshmi, it looks like they're asking, is there going to be a workshop on cloud computing and AI this year for the MSIs, for the idea states?
I think that we'll have this, we're planning for a launch event. We're going to talk about, how do you access these modules? We are not I think there are several workshops that are going on this topic area. I think, the ScHARe platform itself, Think-a-Thons you can think about, are all, fitting into this general theme of cloud computing and AI. So I think, if you have specific things that you're looking for, you can, maybe share more details. But other than that, we're not. There'll be a launch event for these modules.
So there's another question that says, when the sandbox is available midsummer, how will it be communicated?
Yeah, it will be communicated through the ODSS, CIT, NIJMS. But if you have any specific, you want, you can put in your, email here, I will capture it and then I'll let you know, definitely, but otherwise, it will be made broadly widely known.
Okay. And can you give us they're interested in approximate cost of using these modules?
So the cost is going to vary, but I think it's it's going to be about $1 to maybe $2 so for each module. So it's going to be a little bit like some of these modules, like for image analysis, maybe it takes $10, but so these are all not much. Like I said, this is all meant for training, and you can adapt it for your own research if you see that that's applicable. But for the most purposes, so it should be very cost effective.
Yeah, I think that.
Can I just expatiate a little bit more? I asked that question. So the cost, are you saying the cost is going to be per hour, per usage, or could just give us a little more understanding on how we can actually use this, and how it can be cost effective as well?
So in terms of the training, right? Like, so we are going to provide. It will have a data set like that. It comes with, so you're going to be analyzing the data as you go along with that practicum. So, and then also there will be some quizzes that you come across, and you have to answer those quizzes, and you'll see some graphs and so forth. So that's like for that learning part of it, like, so that's the cost that I am projecting for that. So, but again, this is a platform that Cloud Lab that I am saying is a learning platform. It's not going to be for your research. So if it is like you want to do your own research, so then in that case, you may have to get your own GCP account, or use again some of these platforms through the way that you do your research. But we are trying to make it available for the learning purposes.
Okay, so this is for learning, not actually for research.
So these, both what Lakshmi is talking about and the Think-a-Thons are learning platforms. So the Think-a-Thons, when we actually go in and do the actual research, there's going to be no cost to you either. It's going to be, the cost for cloud computing will be paid by ScHARe or by low cost for training purposes. This is very different than having your own research set up. So are there any other last minute questions? And if not, I'm going to move to, I'm going to go back to Luca, and he's going to talk about the collaboration between the cloud platforms that actually use a Terra platform. Both Lakshmi and Luca have kind of highlighted this, but this is a very important issue because once you learn Terra, you're going to have a whole new world opened up to you. Luca?
Thank you, Lakshmi, for your excellent presentation. I'd like to go back to those slides and highlight the potential for collaborations that ScHARe has. So there are several initiatives at NIH, right, to promote AI and cloud computing and in general harness the power of cloud computing. So STRIDES is one of them. STRIDES stands for Science and Technology Research Infrastructure for Discovery, Experimentation, and Sustainability. And NIH partnered with commercial providers to streamline NIH data use. And some of the benefits that STRIDES provide, and you can check them out at their website, include training, discounts on STRIDES partner services, and potential collaborative engagements. And ScHARe is involved in the STRIDES initiative. Other interesting initiatives that all of you may be aware of are Aim Ahead, an initiative born to establish partnership to increase the participation of underrepresented population groups, researchers from underrepresented population groups in the development of algorithms and AI and machine learning models using HR data. And Bridge to AI, whose goal is to expand the use of AI in research, so medical and behavioral research, by generating data sets and best practices for machine learning analysis. What I want to highlight, though, are these platforms, which are based on Terra, as ScHARe also is. So all of us, I'm sure you all are familiar with it, but it's basically an effort to gather data from more than 1 million people in the US. So the idea is to build one of the most diverse health databases in history. Anvil focuses on genomic data, right? So they built a cloud environment for the analysis of genomic data sets. While Biodata Catalyst is a platform that is dedicated to tools, applications, and workflows for research. And all of these platforms being based on Terra means that once you, this creates an opportunity for collaborations across platforms. So for example, to give you an example, studying, doing research at the intersection of genomic data, genomics, and social science. So understanding the implications of how genomic factors and social determinants of health interact in determining health outcomes. And all of this will be made possible or easier by the integration of these platforms planned for the future. And this also means that if you learn how to use Terra on ScHARe, this will open up a world of possibilities for you. So it will give you access to really a wealth of data sets and resources.
Motion detected at the front door.
Okay. Are there any questions for us?
So, Luca, could you please go to the last slide? Just for those of you on the call, we're waiting for the last presenter to sign on. So I'm going to go ahead and sort of do my last part on this so that we give her time to present. So go to the last slide, please, Luca. So this was supposed to be more of the closing, but I think we can do it here and then go back to the ODSS training, because this is a very important part on the training, because the ODSS office offers multiple levels of training from early investigators to senior investigators. And we just had a discussion today where they're going the whole gamut for training. So you don't want to miss Alison's presentation, but we know she's coming in a little bit later. So one of the purposes of ScHARe, as you can see, is that this idea that we need to look deeper with more eyes. What that means is that we need to look deeper, meaning we need more data. We need data to be combined. We need to use the dark data. And what I mean by with more eyes, it's because we need the diversity. We need women, we need people with diverse perspectives to be able to help us design better AI, to understand when biases occur and when the implementation happens and in our communities. This is an interesting part about AI because I love this quote by Jennifer Yu, and she says, AI is opening our eyes to who we are, because we're actually seeing that biases are being trained into the system. And I don't think anyone intends to do that. It just happens. And it also makes a good point in her next part of the phrase where she says, and it plays a conscious role in who we want to become. And this is where we play a role in making sure that those biases don't occur. So we have diverse perspectives with bias mitigation, and we then also take advantage in social science, population health, and health disparities, health outcome research to use this research using big data. Next. So I just wanted to suggest for those of you who are PIs on the call that one of the things that you should start to do in your applications is to budget for staff. it is perfectly acceptable to include Python staff, data wranglers or managers that will help you get your data AI ready. You can also include data sharing costs. You can include the use of data management. All of that can be included in your grant application. You can also include cloud computing costs. You can guesstimate the analytic time, resource time, and as many of you know on the call, we now have a data sharing policy where you have to upload your data, get your data ready, and share it. You can build that cost into your grant application as well. And I'm strongly encouraging you to include both the staff and the time and concepts to do that. ODSS is actually has done these 4 or 3 NOCs for several years now, the first 2 and the bottom 1. I would encourage you all to apply for these as well because they help. They're supplemental grants though, so you kind of have to have an NIH grant to get these, which I apologize. But the one that I want to draw special attention to in this, because it is brand new, is this idea that you can apply for a supplemental that actually allows you to explore cloud use without having your own cloud. ScHARe can offer that cloud service for you. So when you apply for this grant, you can just use ScHARe as that platform that would allow this supplement to be for you to apply for it. Notice that the submission date is in April. So please think about applying to this because it will help get some experience. Do you have any questions about this? Anything? So there is one question in the chat that says, will qualitative data sets be included in ScHARe? And unstructured data. We're focusing first on tabular data sets or structured data, but in the ecosystem that we're going to build, it will have the ability to put unstructured data and for those of you who are new to the terminology, unstructured data is like a media data. And we'll be able to include images and media data as well into the next phase. Another question is, how do you submit this application? You can log on to the NIH webpage and type in ODSS. Maybe Luca or Kevin can put it in the chat. The application process is on the ODSS webpage of NIH, and they'll put it in the chat for you in a minute. And the question is it a supplement to an existing NIH grant? And the answer is yes. So all supplements, unfortunately, have to be supplements to NIH grants. Any other questions? So I think Alison is here with us now. So we will introduce Alison. She is the director of the training for ODSS, which is the Office of Data Science and Strategy. And she will talk to you about their training programs from undergrad to now advanced level investigators. So Alison, welcome.
Thank you, Dr. Duran. Good afternoon, everyone. It's really a pleasure to be here. Can you all hear me?
Yes, we can hear you and we can see you.
Great. I keep getting this little window that says unmute yourself. I thought I did. I'm going to ignore that. It's really a pleasure to be here. I appreciate the opportunity here to tell you a little bit about some of the current efforts at the NIH Office of Data Science Strategy in building a strong and diverse data science community. Next slide, please. So just to orient ourselves, and I think I think this may have been mentioned already, but the NIH Office of Data Science Strategy sits within the NIH Office of the Director in the Division of Program Coordination, Planning, and Strategic Initiatives. Next slide, please. And the primary mission of the office is to provide leadership and coordination to implement the strategic plan for data science at NIH. And this includes the very important component of building a strong and diverse data science community. Next, please. In health research, when we talk about the strong data science community, this community includes people who may not be experts, but who are data science literate. They are not scared by data science. They can read and understand reported outcomes. They know where to find relevant resources. It also includes people who are data science savvy. These are people who are scientists who are data science literate, and they can actively use data science approaches and participate in collaborations or even initiate collaborations with data scientists. And of course, it includes data scientists who have the skills and expertise in various one or more areas of data science. Some examples may include bioinformatics, artificial intelligence, machine learning, visualization, and digital health, which is important, and so on. And they can also communicate what they learn from the data and from, as Harvard Business Review referred to, swimming in the data. And they can creatively display the information. They can also formulate implications from the conclusions and to implement follow-up studies. So in this effort to build this community, one very important factor to consider is diversity. And I'm sure you all know already, next slide please, that diversity is very important in helping to mitigate health disparities, and it also benefits research efforts. For example, studies have shown that diverse teams outperform homogeneous teams. Enhancing diversity helps to expand the range of questions because having people from different perspectives will help you kind of open up that scientific inquiry field. Having diversity will help to facilitate translation of findings to different communities, and it also helps to build that next generation of diverse students and scientists. And it kind of participates in that cycle of trust. Having diversity helps to build that trust that we have with the communities that we serve, and having that trust in turn will help us enhance diversity as well. Next slide, please. So to do this, to try to reach these goals, ODSS in fiscal year 22 established a training, workforce initiatives, and community engagement unit. So the TWICE unit has very clear goals in terms of training, both in the intramural side at NIH, as well as supporting the extramural training efforts. It also supports the development of the extramural biomedical and health research workforce, and it facilitates recruitment into the NIH of data science talents. And we also aim to support those programs that help to enhance data science capacity and to provide training tools and resources that the office has been doing to engage all communities to grow data science knowledge and skills. So we're going to try to hit a few of these today to kind of give you a sampling of the type of efforts that we're looking to support in the next year or two, especially. Next, please. So in our extramural training space, so we really try to work very closely, the NIMHD included, and it's a very strong partner of ours, but we really try to work all across the NIH institute centers and offices and really leverage that currently existing kind of a massive network of training programs that's there already. What we try to do is to promote data science within that network with specific and high priority on enhancing the diversity and supporting that pipeline all from pre-college students, so pre-college students all the way to early investigators. So for example, some of the programs that ODSS will help to co-fund in fiscal 23 include the diversity supplements, the Diversity F31 Award, Diversity Focus K Awards across NIH, and some of the T32s and R25s that have strong recruitment plan to enhance diversity. For the R25s, we're especially focusing on the pre-college research education programs. Next, please. And for the, sorry, I forgot to mention. So for those training efforts that I just mentioned, the contact information at our office, the contact person at our office is Dr. Brian Kim. Now, in the promoting capacity building space, we really want to put in investment in promoting data science capacity building in low resource institutions. And here again, we're collaborating with different institutes and centers across NIH to really support programs that develop human capital, that grow partnerships, and that enhance their research and data science infrastructure. So some of the examples are listed here. I'm sure you're familiar with some of this. I do want to specifically mention that there has been a supplement to enhance data science capacity at low resource institutions. We are planning to issue a new NOSI for this effort. So definitely keep an eye out for it as it comes onto our website. For these efforts, the contact person at our office is Dr. Rafael Isopahi. Next, please. We're going to switch gears a little bit now and look at a inward kind of process, while outward in terms of recruiting from the extramural community, also recruiting from the industry for those established data science talents. Individuals with established data science talent and expertise to come to the NIH to work 1 to 2 years. This is through a program called the Data and Technology Advancement National Service Scholar Program. The Data Scholar Program, in short, really aims to attract that talent to come to the NIH, not to the intramural research program, but to the extramural program offices at NIH to help optimize and accelerate data science in biomedicine and health research. These individuals, these scholars who are selected are strongly encouraged to transform some of the approaches that NIH has taken that will hopefully help to increase the efficiency and also to help tool development and analytics and to inspire innovative research. So like I said, this is a 1 to 2 years commitment type of project. They can commit to up to 2 years. It can be full-time. We encourage full-time commitment. It could be part-time as well if necessary. So in addition to their own project when they come, they also are encouraged to participate in work groups and collaborations across NIH. And these scholars indeed have contributed in many different ways to the NIH. We have so far had 3 cohorts, and we're about to open application probably later this month for cohort 4 recruitment for 23. Next slide, please. So I want to share with you a little bit of the accomplishments of the scholars to give you a better idea of what the program is like. So far in the 3 cohorts, we have recruited 20 scholars. They have worked at 14 different institute centers and offices here at the NIH. And 7 of the scholars have completed the program and have gone on to their next step. So some of the example accomplishments this year, include peer-reviewed publications from our scholars, include technologies, products, inventions, patent applications, and shared resources that's been developed, and also oral presentations. And this is just a small slice of what they have accomplished. Next, please. I want to emphasize again that ODSS particularly encourages applications from individuals from population groups identified in the NIH Notice of Interest in Diversity as being underrepresented in the biomedical, clinical, behavioral, and social sciences. These include, but are not limited to, women and individuals from different racial and ethnic backgrounds, individuals with disability, and individuals from disadvantaged backgrounds. Next, please. And then a few words about the eligibility and application for the Data Scholar Program. The applicants must be US citizens, non-citizen nationals, or permanent residents. Right now, the program requires that the applicants must have a doctoral degree of some kind. Usually in the some data related data or biomedical and health research related fields. And as I said, it's for people with established expertise in data science. So we're looking for individuals with advanced experience in data science or related fields. These are just some examples listed here. It certainly is not an exhaustive list. The application is really relatively straightforward. When we open the application on the website, there will be a link to an online form, and each applicant is allowed to choose up to 3 projects that they are interested in. And then within the cover letter, we ask that the applicant describe their motivation of why they want to come and be a scholar, what kind of contribution they think they can bring to NIH, and to offer a vision of what they feel would be the impact of data science in biomedical research and health sciences. And importantly, also how they feel they can contribute to enhancing the diversity in the data science community. And then, of course, resume. We do not require references to be included, just their contact information. We will be reaching out for contact. So I would really encourage you to look at this and also help us spread the word and check out our website for that. The last couple minutes, can we go to the next slide, please? I want to just mention some effort that's coming soon of the FIRE training that will be made available to the extramural communities. This is a interoperability standard that facilitates clinical and healthcare data exchange. This FIRE training was carried out here at the NIH earlier in the year, and it was really received with enthusiasm, and it went over very well. So this is planned to expand this training and make it available to the extramural communities in 2023. So to find out more information about this, please feel free to check out the website. The link is there on the page, and the contact person you're looking for is Dr. Steve Zhang from our office. And lastly, next slide, please. I will end by kind of pointing you at the TWICE team. Can we have the next slide, please? Thank you. So we have Raphael and Brian, who are program directors, and Nick, who just joined us. He is a data science training specialist. So the email will get all of us. We all look at that email, dsworkforce@nih.gov. I encourage you to contact us with any questions, anything that you've heard here today. There's our main webpage, ODSS webpage. Certainly, please do browse over the webpage. There's a lot of information there, but specifically, I want to especially point to 2 places. One is the data science funding opportunities page, where we try to collect and update very frequently all of the currently active funding opportunity announcements at NIH that is data science relevant. So please do check it out to see if there's something in there that you might be interested in applying to. The second place I like to point toward is the data science job opportunities at NIH page. The job board here are the data science, the current federal positions that's open at NIH. that require someone with data science expertise at all levels. Some of them are beginner level, there's postdoc positions, and then there's the actual federal positions as well. I think that's it. Thank you so much for your attention. I'm happy to answer questions if there's any.
Thank you, Alison. Is there any questions for Alison? Yes, she did a really good job, Alison. No questions. Luca, can you go to the last slides, please, with the links?
Sure.
There is a question, Alison, about where do you go for the scholarship information?
The Data Scholar program?
It says scholarship. So whoever submitted that, if you can ask the question, that would be fine.
Okay, well, if it is the Data Scholar program, I'm going to put the link in the chat of the current 2022 webpage. The application portion of it is not open yet with the active link because we haven't opened for this year. And the projects that are currently listed on that webpage are the ones for 2022. That'll give you an idea. There's a one-pager if you click into it of every project. So it'll give you an idea of the type of projects that's out there. We will be updating later this month with the projects that are selected for this year. Okay.
I have a question.
Okay.
So, as you mentioned that this new project is going to post it for 2023. So we have to have like 100% research interest in those fields or research experience in those fields, or just having like data science background is enough for the application?
So these are meant to be a 1 to 2 year, so fairly short duration, and within which great outcomes are expected from the scholars. And so when they come in, we want them to come in knowing generally what it is that they will be doing. So there will be a field of a nice selection of different type of projects for the scholars to select. And if this year you don't see what you need, then maybe next year you can come back in and see if there's other projects. If there's something that you really that you really want to do, that you feel is a great idea, but you don't see it on there, feel free to reach out to us and we can definitely chat about it. But generally, we expect the applicants to choose their top 3 projects that they are interested in exploring.
So
I'm sorry.
You meant, I think I might be able to help you with that too, because we are one of the groups that actually use data scholars. So in general, you need to have some background in data science, and many program people like myself will interview you and will explain to you what our projects are. And then you go through and there's a selection process where we select you and you select us. And that's how you end up with the type of project that you're going to work on. And then you have 2 years to work, up to 2 years. It can be 1 year or up to 2 years as a data scholar to work on that project.
Yeah, my main problem is I'm a data scientist. I have a PhD in statistics, and my problem is I don't have a lot of health-related experience. So that's
why we do this program.
Yeah,
because we're gonna help you learn the health part of it. So you're perfect for this program. So please apply.
Yeah. Thank you.
Thank you, Deborah. That's great.
So I want
So I also have a question. So for people who are working and they have some sort of data science background, do you have time protected sort of incentive for the institution, or is mainly for those who are looking for new opportunities?
So the way the program works is that you would just take like a leave of absence from your position, and then you go back to it. So that has been one of the issues. You probably should make sure you can take a leave of absence for a year or two and then be able to work on the program. So you can be employed and be a scholar.
Yeah, thank you, Deborah. I want to add that that we do encourage the data scholars to be full-time here, but we do have data scholars who are part-time, who are engaged part-time. So that is something that can be worked out. We would need to, it's a case-by-case kind of thing. So as part of the application, there's actually there's a place where you can indicate if you want to engage full-time or part-time. And on the other side, the ICs who have put out the projects have the same kind of thing. So they can, you know, if the IC is looking for a full-time person, then they may pass you up as a candidate. Okay, I do see one quick question that says email alert. If you go to the ODSS webpage, on the front page of the ODSS webpage, scroll to the end of that page, there's a sign up. Once you sign up for that, you get emails always from our office, like on a weekly basis.
So we have come to the close of time. For those of you who have further questions or want further information, you can always email me. And I can get you in touch with Alison or Lakshmi. They also provided you with their email links. I want to thank you all for, it looks like hundreds of you stayed with us. So thank you all for participating. And thank you all for listening. I hope that you continue your participation. And for the next Think-a-Thons, please look at the links above, and please continue to join us. And I look forward to working with you for the next several years. I'm going to put my email into the chat, and we'll leave the chat open as you sign off so people can get access to my email. And again, thank you very much for coming. If you have any other questions, feel free to email me as well. Also suggestions. Thank you.
Thanks, everyone. Hope to see you next month.